After having looked at the reduction for heating and cooling in the previous video, we now look at the reduction of overall energy consumption of buildings, including appliances and domestic hot water. This table shows the consumption that we accounted for in terms of overall home appliances as well as domestic hot water. And for the domestic hot water, we assume a heat pump water heater for each building. In this table, we can also see how California Title 24 is the only standard that requires PVs to be installed on site, depending on the size of the building, in order to generate renewable energy. The only exception is the very first project at the top, which is too small for that requirement to apply. Once that is included, this is what the breakdown for site energy consumption overall looks like for the median values across all projects considered for the different building standards. On the left-hand side, we have the 2018 Energy Code, IECC, and then on the far right, we have the PHI Passive House. And for each standard, you see the sum of heating and cooling in dark gray. And then in medium gray, you see home appliances. And in light gray, we have the domestic hot water. You also see in yellow the contribution of PVs that California Title 24 receives in offsetting these requirements, this energy consumption, thanks to the requirement of California Title 24 for PVs to be installed. But that is a compensation strategy in that in terms of building envelope overall, the California Title 24 does not really push the limit much compared to the 2018 regular IECC Energy Code. In this table, we see the reduction compared to the 2018 IECC code for the overall energy usage for each project and for each building standard considered. And this is what the reduction looks like for each building standard. As I mentioned earlier, California Title 24 looks good in this graph because they compensate energy that they do consume by means of PV system generating electricity on site. Other than that, California Title 24 is very similar to the regular 2018 IECC code. Now, of all the building standards that we have considered so far, PHI Passive House outperforms every other standard in terms of energy consumption reduction by reducing the need for energy by over 50% overall compared to the 2018 Energy Code. And the three standards following include PHI Low Energy Building Standard, the 2018 Fuse Plus Core Standard, as well as the 2021 Fuse Plus Core Standard Performance-Based, with PHI Low Energy Building being the better of these three. And these three are around 40% reduction compared to the 2018 Energy Code in terms of overall energy consumption. So looking at the energy use intensity, EUI, per building standard, not including yet EV charging, this is what it looks like in average. And you see that the ones that is, again, California Title 24 in this graph looks good thanks to the compensation that they have by requiring PV systems to be installed in projects, whereas all other building standards were calculated without any PV systems. So in this regard, the PHI Low Energy Building, PHI Passive House is the one that is most efficient across all projects considered, followed by the PHI Low Energy Building, and then third is the 2018 Fuse Plus Core.